Powoli zaczynamy drugą część spotkania. Mam tylko informację od dzisiejszego sponsora. Mieliśmy problemy logistyczne z poczęstunkiem, natomiast nie powtórzy się ta sytuacja następnym razem. Także zapraszam już za miesiąc.
Pizza została przełożona na kolejne spotkanie.
Tak. So now we start the second session for about our language. I'm happy to introduce Dr. Nico Jacobs.
Yeah.
Stage is yours.
Thank you. First, I have to apologize. I don't speak any Polish at all. I only got as far as Lodi. It's the only word that I learned in the past couple of days, but it came very handy with all the nice sunny weather over there. Although I guess he was talking about the lack of pizza, if I understood well. So I guess you're as hungry as I am. Okay, well, I'll try.
There will be, you know.
Okay, I'll try to be back in a month. Cannot make any promises though. Okay, so I'm Nico, and as you can guess from my email address, I'm from Belgium. That's why my Polish is didn't go further than the ice cream thing. So if you wonder what's a Belgian guy doing in the Warsaw SQL User group, the answer is UTU. I work for that company. We're a training company delivering Microsoft training throughout Europe and the Middle East. And this week I'm at Circle K, maybe you know Statoil a bit better. That's more or less the same company. And well, since I'm here and I hate watching Netflix all evenings, I thought why not go ahead and see whether there is a session at the SQL user group that I can deliver. So at UTU, I'm the SQL guy. Started over there 13 years ago when it was still SQL Server 2000, and we didn't have much of BI in there. Well, there was analysis service and it had a data mining engine, but things weren't the way they are right now. So over time, more and more stuff was added to the list. And one of the recent things that Microsoft got interested in is the R language. So that's more or less our subject for today. Just out of curiosity, who already played a little bit with R? Okay, I'd say 10% of the room at most. Okay, so good news is you do not need to understand the R language to attend the session. The bad news is when you walk out there in an hour from now, you will not be an R expert either. Okay, so what is going wrong? Okay, I'm back. Okay, so we'll see. What are we going to do then? It's not just about the R language over here. It's more or less how the R language and the Microsoft stack fit together. So I guess most of you are Microsoft-oriented developers or BI people, and yeah, you're probably familiar with, I guess SQL for sure, maybe Visual Studio, maybe Power BI. I heard Power BI being mentioned a lot in the previous session. If you don't understand the language, you only pick up those words that you recognize. Power BI was definitely in the list. So what I'll go and show you is how we can use that R language in Visual Studio, in SQL Server, in Power BI, in reporting services. And those are the different environments that I mentioned over here. So we can use that R language in a lot of different environments. But something that many people are not familiar with is that we also have different flavors of R. Before Microsoft got started with this, you mainly had the open source R version. But Microsoft now introduces 3 variants of R as well. Some of them for free, some of them not. So also want to go ahead and talk a little bit about what are these different types of R distributions and how can we use them and why would you use them. Along the way, we will go ahead and show you some R code. Usually I start with a couple of slides, but this evening I have a bit of a problem. I noticed too late that I'm running in a very dangerous situation over here. I have €1 left on my Azure credit. So let's first start with demos, and hopefully my virtual machine runs long enough. I only need it for one thing, so it's not that everything runs on that particular one. Okay, so first question, why would we go ahead and use R? Let's pretend for a moment that you work for AdventureWorks. I guess many of you are familiar with the sample database. And you know, they sell bikes all over the world, and they go like, well, Nico, we have this fantastic weekend, very sunny weather, so a lot of people might be interested in biking. I want you to figure out what is typical for people who bought a bike in our company over here. First part, of course, is the SQL part of the story, going into your historical sales, fetching information about all your customers to figure out which of those customers bought a bike and which one didn't. So for that, we can use Visual Studio, amongst others. You know, Visual Studio has a lot of things in it that you have in Management Studio as well. For instance, we can run queries, we can look into execution plans. By the way, I always like to live on the dangerous side of technology. As a trainer, I mainly play with new stuff to see what works and what doesn't work. So in my demo over here, the SQL Server that I'll be using for most of the demos is the vNext version running on Linux, just to see what works and what doesn't. Next month, I'm giving a session about what doesn't work on the SQL Server running on Linux. And so far, it is a disappointing thing because everything seems to work. So maybe we'll bump into some things that don't work. Nevertheless, okay, so let's pretend you first spend half an hour writing SQL queries, doing all sorts of calculations and joins and whatever. And when you go ahead and run these things, you get back the table. And in there, you see, amongst others, a bunch of properties of your customers, when they were born, their gender, a couple of things. We loaded some demographic data as well. Of course, you don't know for your customers how much money they make, but if you know their address with demographic data, you can get a bit more. And amongst others as well, we have over here this thing whether these customers bought a bike or they did not buy a bike. So that's the historical data that we have, about 18,000 rows over here. So far, so good in the relational SQL world. But now you want to start with things like machine learning or statistical stuff like calculating correlations or plotting these things, etc., etc. So the way I solve that problem over here is in Visual Studio, you have a free add-in. It's called RTools for Visual Studio, RTFS. So if you have a Visual Studio, you just need to download something like 10-20 megabytes, run that installer, and then inside Visual Studio, you can go ahead and create new projects, and those projects can be of the type R, shortest name for a project that we have over there. Just one template over there where you start with an MTR project. But as soon as you are in that MTR project, you can add all sorts of things. So what I did first was I went ahead and I added over here a new item being a SQL query. So you can add, for instance, a SQL query, and that's how I got started typing my code over here and running my query and looking in my execution plans to see whether I could make that query any more performant. But now as a next step, what I'm going to do is I'm going to add to this project an R script. Okay. So in R, what can we do? R is a language that you typically run through a REPL loop. So you read an expression, you evaluate it, you print the result, and then you go ahead and loop over those things again. So in such a project, you can use this interactive window over here, which you can just use as your watch. So anything you type over there is immediately evaluated, and date is one of the many functions that we have in R. So you can just evaluate things immediately. But of course, if you want to rerun these things again tomorrow, you better write them in a script. So if I would type over here my date as well, and I press enter, nothing happens. But if I do a control enter, maybe I should go ahead and first pin this window over here. So when I do a control enter, then you see that he just pushes whatever you typed over there to this interactive window. It gets evaluated and we see the results. So in here, I need to start typing R code. If you don't know R that well, you can be lazy. If you're in IT, usually that's because you're so lazy that you want to spend a lot of time making sure you spend less time the next time you do something. So snippets. Probably you know snippets from Management Studio, or maybe you're a web developer or whatever, and you use snippets in Visual Studio. With snippets, we can go ahead and reuse pieces of code. So in an R project as well, we have a whole bunch of snippets for, amongst others, talking to databases over there, or doing other things like presenting graphics, etc. So in my case as well, I have some snippets that I added to this. So one of my snippets is to go ahead and load data using a connection to a relational database. So with those snippets, life becomes easy, because if you drag them in there, it spits out a bunch of code. For those of you who are not into R, library is very important. The R language itself is pretty simple, pretty basic, but they made more than 10,000 packages with all sorts of extra stuff that you can do on top of this. Fancy visualizations, all sorts of machine learning stuff and all those kind of things. So one of those is the R ODBC, and that's to connect to any ODBC source. Pretty straightforward. So if you want to connect to something, you need two things. You need a connection string. But this connection string over there is just a placeholder. That's not my actual one. I want to go ahead and connect to my SQL Server, but I don't want to show you the password. So what I did was this. If you go ahead and go to your R tools over here, you can add a database connection. So over here you can just simply specify which server you want to talk to, Windows or SQL authentication, type in your stuff. And as soon as you enter this, it's automatically stored in your settings, in your settings object. So I can now just go ahead and say, in my settings, there is one database connection that I gave the name DB connection. So I just want to go ahead and get my connection string from over there. Second thing that we need is we need to go ahead and kick off a query. So this thing over here is a variable. In R, we don't use equal signs. R is a language that comes from the world of statistics, so mathematicians. And mathematicians don't like equal signs the way we use them. A equals 5, and next line you write A equals 7. Oh, that means that 5 equals 7, and the mathematicians start to panic. So their interpretation of the equal sign is a bit different from ours. So they use this arrow thing, which means we put whatever is on the right-hand side in a variable that you have on the left-hand side, and then they're less afraid. So you'll see a lot of these things in the R language over there. Okay, so this channel is now a variable, and it holds my connection. So next thing I do is I call the function kick off a query on that connection, and this is the query. That's not the query. I want to use the query that we wrote over here, that SQL stuff thing that we had over there. So here as well, Visual Studio does a couple of nice things. I could go ahead and say, don't hard code a query over here, but just go to your Solution Explorer, grab that window where we were writing our SQL query. Hey, Visual Studio, are you hungry as well? Yeah, doesn't really seem responsive, huh? Hello. Okay. That's better. Let's give it another try. Solution Explorer. I go to my SQL window over there, drag it in here, and as soon as I release, it generates again some code for me, which simply says, take whatever was in that query window and use that one in this spot over here. That's now handy, because if I need to switch back and forward between changing SQL code and changing R code, I never need to copy paste that query back. I just use a reference, which is much easier to work with. Okay, so don't worry about what they do in here. We hope that Microsoft knows R much better than I do, and this is something sensible. So now we can go ahead and run this code. So if you click this icon over here, you send the whole thing into that thing over here, and it went ahead and executed this. So now we have something called the input data set, and in that input data set it stored whatever was the outcome of this query. So my 18,000 rows are now in here, and now I can start to do R stuff over here and start typing all sorts of things. You don't want to watch me typing all night, so I already prepared a couple of things over here. One very easy function that you can use is summary. Give me simply a summary of this data set over there. So if I would now send this thing over here, we will see for each and every of our columns that we have in that data set. Let's for instance just start with these ones over here. some information. It depends a little bit on what your data set was. If your if your column at hand was numeric, let's maybe scroll to the next one over here. Something numeric like your yearly income. It just shows you minimum value, maximum value, median and mean value. A couple of numerical pieces of information to figure out, for instance, whether you have outliers. If somebody's age is minus something, something weird is going on. If it's not, then it will simply show you for the most common values how often they occur. So education level, for instance, we have so many people with such an education level, etc. How long would it take you to do that with T-SQL? Definitely, yeah. I get even more hungry then if I have to wait for all that. So, so for these kind of things, R is a very interesting language, because the things that are really tough to do in SQL are sometimes easy over here. You only need to figure out which of these things you need. So we have help. If we press F1 over here, then I have this help window that pops up, and that goes ahead and shows me the manual, the official R manual, and I can read through these things. Pretty boring on a Thursday afternoon, a Thursday evening. So another thing you can do is you can do Control F1. And then you just go and pick your favorite website. In this case, the default is Stack Overflow. And he grabs that keyword, he adds the keyword R, and shows you that on Stack Overflow. So then you can read on Stack Overflow what people are talking about that particular function over there as well. So that's one way to figure out. The R language exists for more than 20 years. So you have a ton of websites out there with information. Google, Bing are your friends. Just go ahead and Google things like how do I do whatever you want in R. Read through some of the examples over there. Combine that with the manual over here. The IntelliSense, if you start typing, for instance, let's say I want to go ahead and later on, we just want to, for instance, create a table over there. So when I start typing, you see the IntelliSense popping up, showing me the methods that we have, the parameters that you need, the kind of things you're used to if you did C# or whatever kind of programming. Okay, so for instance, I quickly want to figure out how many people have which types of English educations. So there I see all the possible values. Or I'm, for instance, wondering whether there is some correlation between your age, whether you do or do not buy a bike, and how many cars you own. So then there is the cor function that simply computes a correlation. Now, before I run this one, I first want to talk a little bit about these very weird things that I'm writing over here. If you have a variable that holds data, we call that a data frame. In my case, it was called input data set. Between square brackets, you can simply use coordinates. So from the 5th row, I want to see the 3rd column. Okay, so then over here we get back some thing over there, this AW whatever. So that's the coordinate system. So what we can do as well is we can, for instance, say 1 till 20, and that goes ahead and produces the first 20 numbers. So if we combine those, and I want to see, for instance, the first 10 rows, then I could, the first 10 rows, so from 1 till 10, but only the 3rd column, I get back these kind of things. I want to see all columns from column 3 to column 6. Okay, so there I get for the first 10 rows, columns 3 till 6. Of course, that's more or less what I'm doing over here, except if you don't type anything, R, that's what I really love about R. R usually has pretty clever defaults. So if you, for instance, say, oh, I don't mention anything about the rows, they go like, well, probably you mean then all rows. So this comma over here simply means grab all rows, and I just want to filter down on the columns. And instead of filtering by position, you can also filter on name. So that's what I do over here. Just grab the age, bike buyer, and numbers of cars owned columns from this table over there, and compute the correlation over all the rows on these things. And then over here we get back some information. Age is 100% correlated with age. Wow. Oh, you know that already. But for instance, bike buyer and age have a negative correlation, which means if your age goes up, the amount of bikes you buy goes down. Okay. Number of cars owned has a positive has a negative correlation with bike buyer as well. If you have more cars, you buy less bikes. Seems to be logical, but in this way we can quickly verify these kind of things. Or for instance, if you have now 40 columns over there and you wonder which of those columns are most strongly correlated with these kind of things, yeah, you just run it on all 40 of them, of course, and pick the highest ones. Okay, time for some extra things. As I mentioned, there are more than 10,000 libraries out there. So one of those is gmodels, and in that we can create what we would call a pivot table. So cross table over here computes me a pivot table showing me all combinations for bike buyer against all combinations of education. So in that way I can see which education levels correspond with the amount of bike buyers. And I know these things look a little bit ugly over here, but we will work on that in a moment. So people who do not buy a bike, we have so many bachelors, so many people with a graduate degree. So that's 12% of my total population, or 43% of the people in this column, or 25% of the people in this row. That's the kind of thing that you get. And if you can't remember, over here at the top, they will go ahead and tell you that kind of stuff. So once again, with just a few lines, we get a whole bunch of information. I don't know about you, but especially on a Thursday evening, looking at a bunch of numbers, we didn't survive the wild animals 50,000 years ago by looking at numbers. Our brain is wired for images and that kind of stuff. So visualizations, we have a bunch of those as well. So for instance, if I call this hist thing over here, I just compute a histogram. In this case, how is the age of my customers distributed? And then you get these plot windows over here. So, oops. So there we now go ahead and see how these things are distributed. We can make a PDF out of this or save it as a JPEG or whatever. You can create more fancy charts than this, but then you have to write a lot more lines of code. For this, there is, for instance, ggplot, a very famous library. Maybe you ever read The Grammar of Graphics, which is a sort of academical approach on how you should create plots and what is in there and what you should worry about. So the R implementation of these things gives you much more fancy charts, but you already got a couple of very fancy charts in the first session this evening, so don't really have many more. I want to focus a little bit more on the statistical part of the story. So next thing is we need to figure out what is typical for people buying a bike. And that's where machine learning comes in. So one of the libraries that we have in R is one to go ahead and build trees, build decision trees. And with those decision trees, we can then go ahead and figure out what is typical for people who will buy a bike and what is not. So let's first load a couple of libraries. And then what I'm going to do over here is I first ask how many rows do we have. So with the length function, you can simply go ahead and figure that out. And then what I really love about R is it easily allows you to create either subsets from a bigger set or generate artificial data. I use R from time to time because I have something I need to demonstrate in my training sessions. I don't have really enough data for that. I need 20 million rows with an age not uniformly distributed. I mean, yeah, I know the rand function in SQL, but it doesn't have much of control over there. But in R, we have a ton of functions to create artificial data that is normally distributed or follows Poisson distribution or all these kind of distributions that you have out there. So in this case, I simply ask him, pick a random sample of 2/3 of the number of rows that I have over here and call that my training set. If you do machine learning and you let this thing build a model, then you have more or less the same problem that you have as a teacher. Right? You're telling your students a bunch of things, and then you wonder, like, did they really got it? So to test this, yeah, you go ahead and organize exams. Yeah, we're going to organize an exam at the end of this session as well. Huh? You know, you can win these kind of things, so just be prepared. Okay, so you need to organize an exam. But if in the exam you would ask them the exact same question as what you showed them when you were learning things, then a relational database would be the best student ever, right? Because you just need to select from what you've seen and there is the answer. That's not really understanding things. So your teacher in the past probably asked you different things than what he showed you to learn stuff. we tell you 1 plus 3 is 4, and then we ask you how much is 5 plus 3. Okay. So the same thing over here. With machine learning, we build a set that we will feed into the system to learn from, and then we will build another set for which we already know whether these people bought a bike or not. And we will feed it in the system again, and this time ask them, what do you think? And then compare whether they got it right or not. So that's why we built over here a training set, and we use all the others as a test set. So once again, you can simply put a minus in front of all these positions that we have over there. So these are the ones that we pick. Just take the opposite of that one as the ones you don't want to have. By the way, if you're interested in these kind of scripts over here, just send me an email and I can go ahead and provide them, or maybe the organizers can put them on a site somewhere. Then you can take a look at those things later on. Okay, so as soon as I have this, I call this function over here. And then this is something that I need to explain. If you start looking into R, you see these kind of things a lot. This basically means this is the thing I'm interested in, but I don't know it. And these are the things that I do know. So for instance, for my new customers, I know how many children they have and what their gender is and their age. And I wonder, will these be bike buyers or not? So the tilde, whatever is to the left of this, is the thing you don't know. Whatever is to the right is the thing you do know. Okay, so the system went ahead and learned a decision tree. So in a blink of the eye, it, for instance, built this tree where it says, oh, if you have more than 1.5 car, yeah, the system doesn't know that the number of cars was an integer, so it just plays safe and basically means if you have at least one car, sorry, if you have at least 2 cars in this case, then in general I would not think you would buy a bike, but it depends. It depends on more things. For instance, are you poor? Well, this is American data. If your yearly income is less than 65,000, American standard, that's maybe poor. So then it depends. Then I still think you, with your many cars and low income, you're not going to buy a bike. But if your income is high and you have less than 4.5 kids, then I do think you're going to buy a bike. So in this way, it went ahead and made a whole model with all these kind of things. And if you prefer to show that in some Word document or whatever, you can throw it again in your plot and you get these more fancy visualizations over here that go ahead and show you these things. Okay, you can also call summary on all sorts of things. The first time I fed into summary a data frame, and it told me min and max values and these kind of things. But if you feed in a machine learning model, for instance, it can go ahead and give you all sorts of information. Some of them are pretty boring on this Thursday evening. But for instance, over here it says, well, this is the main split that I used, but I considered these as well, and this is why I picked that particular thing. So you can get back a whole bunch of things if you really want. Okay, let's go ahead and run the whole thing. So over here, what I now did is I built some model over here using C5.0, one of these decision tree algorithms. I asked him to make predictions on my test set, what they think people will really do. And then over here with cross table, I go ahead and compare the real outcome on my test set with the predicted outcome on my test set. And then over here, we go ahead and see things like the kind of mistakes that the system makes. So people who do not buy a bike, 2,200 times I predicted that they would not buy a bike, but 928 times I thought that they bought a bike. The other way around, if they do buy a bike, 2,191 times I got it right, but 839 times I got it wrong. And now the question simply is this good or is this bad? And if it's bad, yeah, then you need to spend a few more hours trying different columns in there, trying to manipulate the data, etc. For instance, if you do machine learning, don't give the system somebody's email address. You don't want to see a pattern. If your email address is nico@youtube.be, you're going to buy a bike, else you're not. But if you would just take the last portion of it, if your email address ends on .be, then you're buying a bike. If it ends on .pl, you're not. Probably the other way around, because it's much more flat over here than it is back in Belgium. So I think biking is better than over here Okay, so that's how we can prepare the data, play with these, etc. Yeah, shoot.
Is order of column important?
In this thing over here, no, it's not. But it could be for some of the algorithms. So it depends. You always need to press F1 and read the boring explanation if you really want to be sure on these things. Yeah. Okay, so I hope that with this you got at least a bit of an idea why we would use R on top of our SQL language, why it can do things that either are very hard or impossible to do in T-SQL. And then in Visual Studio, you can now nicely mix the two. You do in T-SQL what you best know how to do in T-SQL, and you switch to R for the things that are difficult over there. Questions on the Visual Studio thing?
I have a question on this, like input to the model. What's the easiest way to tell R to choose the best variables, the right ones that are important, and doesn't use those that are not?
So how did they came up with this one? Well, a very simple thing that you could already do was that core function that we saw over there, which computes the direct correlation between the thing you want to know and all the other ones. And everything with a high correlation is a good thing to start with.
Okay.
And all the other ones you ignore at first. To be really honest,
right?
Sorry?
There is no way to choose them automatically in the code.
Well, you can create your own functions in R. So with that, you can go ahead and say, let's first call core, then filter the results, and only pick those that are above average on the correlation, and then build a set out of those, and then you call your function over there. So yes, it's possible. Is it very easy to do? No. Plus, there are much more advanced ways to do this. It's called feature selection. So go to Google or Bing, and type feature selection R, see what comes out of it, and there you'll find out a lot more than just that stupid core function over there. So there are better ways, but I don't want to get too statistical on a Thursday evening. Yeah.
I had a question about this input data, the query that you put it into the code. Is it possible to manage some local variables from the query in order just to choose what you want to analyze, or do you have to?
So you want to have some variables over here and feed in.
Yes, and then just when playing with R, just declare this variable, and so you can use it.
In this particular case, it can become a little bit tricky because you then you need to start figuring out what they do over here, huh? All this kind of stuff over here. And because of that, it's tricky. But if you had hard-coded your query over here and then want to make this thing dynamic, once again, we can, in R, create our own functions, which could take a query and substitute things in there. So there are all sorts of ways. Plus, if we wait for another half an hour or so, we will see R integrated in SQL Server. But that's only for SQL Server 2016. This thing that I'm showing you over here works with any flavor of SQL or Oracle or whatever you're using over there. And then we will see that the parameterization is a lot easier. So if it's on SQL Server 2016, I would say wait for another half an hour. And then, half an hour. I need to speed up. Okay, other questions or remarks at this point? Okay, so that's the Visual Studio. Now I do have a remark. That is, what if my query over here does not return a few thousand rows, but a lot more than that? The problem with R, as we see it over here, is whatever data you have needs to be loaded in memory. If it does not fit in memory, it fails. So that could be a problem, because on my machine over here, I only have 16 gigabytes of memory, and of course, a lot of it is already consumed by other things. So I have very little left over here. Another problem is, imagine you do this within your organization, and you're not reading only from a database, but you're also reading from files, etc. Then everybody needs those files on their local machine. So they need a lot of memory on their local machine. They need to have all copies of these files, and you know, sooner or later somebody has a more recent version than the other, and all sorts of inconsistencies start to occur. So one of the fancy things that Microsoft did, and now all pray to the demo gods with me that my virtual machine on Azure is still running. One of the things that they did is you can go ahead and create remote workspaces. So if I click on this thing, and my virtual machine is still running, I didn't run out of my €1 that I still had over there on my Azure account. So then this thing will now switch over to a virtual machine. In my case, a virtual machine running in the Azure cloud, but it could also be just a real machine that you have within your organization. And over there, if I now ask for my memory limits over there, it will go ahead and tell me that I have 65 GB of RAM over there. So now on that central machine, I can put my files, my big files, and all my data scientists, and that's a fancy name for what we're doing over here, all the data scientists could be connecting to that remote machine over there and running over there these heavy loads and access these files locally. So you just type things over here, but any statement you execute is sent to the other side, to that machine over there, and runs in that context. So in that way, you're also sure that everybody uses the same version of R within your organization, has the same versions of libraries installed, etc. So these remote workspaces were recently added to our R tools over here. Okay, so we as a data scientist spent quite some time figuring out what is typical for people buying a bike or whatever problem you want to solve. But now you have to show this to management. They don't really go ahead and love all these kind of Visual Studio things. So how can we go ahead and wrap up these things in a different environment that's easier to present to management? Well, you talked a lot about Power BI, so let's go ahead and use Power BI. Okay, pulling some data from, in this case, a file. No, sorry, it was already in the list over there. So I'm grabbing a text file over there. And I don't know whether you have the problem over here, but in Belgium we have a big problem. Let's show our big problem over here. Where is it? This is the one. This is what our tax forms look like. In the past, we used to have about 700 parameters that the government needs to know from every civilian to figure out how many tax they need to pay. And our current government said, we're going to improve upon things. Now everybody thought that they meant with improving less parameters, but now there are more than 800 parameters you need to provide. So they don't even provide the codes anymore. They just say, fill out the codes that apply to you and put the numbers right next to it. We call it a lottery form in Belgium. So we want to make things more simple than that. So I thought, well, let's see whether we can do this. So what I have over here is simply, this is the one, a text file, and in there I just collect, what is it, something like 5 or 6 parameters from people, and based on that I want to go ahead and predict how much taxes they have to pay, and one of the columns is how much tax they are paying right now. It's artificial data, of course, generated by R, by the way. Okay, so let's get started putting this thing in Power BI Desktop. So this is the one. And I want to show you something that has nothing to do with R, but I'm so proud of it. I find it such a fantastic thing that I wanted to show it to you anyhow. This week they released a new version of Power BI Desktop. And one of the very fancy things they did in there is making it really easy for lazy people like me to clean up your data. Because those of you familiar with Power BI Desktop, you probably know that from these kind of columns with a couple of rightly chosen transformations, you can clean up that data. For instance, in this case, this is the last name, first name, and the number of children that people have, all squeezed in one string. And for my analysis over here, I just need to know the number of children that they have. So if you download the most recent version, you can say, I'll just show you what you need to extract and figure out for yourself how to do this. For lazy people like me, that's really super. So in this particular case, I will tell him, based on this column alone, I want to see for this thing the number 3. I press tab, and he goes ahead and says, well, then you probably need a 1 for this and a 5 for that. Yeah, here is the code that you need for that. Great, huh? I really love that feature in Power BI Desktop. Apparently I'm the only one. Okay, sorry for... okay, let's rename this column. Rename. Okay, so this is the number of children. Okay. But now I want to have an extra column in there with the estimated amount of tax that you need to pay. So for that, unfortunately, we cannot go ahead and use this column from example thing over there. But if we look into the list of transformations that you have in Power BI, you can go ahead and run our code. Okay. No fancy interface, no IntelliSense, syntax coloring or whatever. That's the bad news. But what the system did is, all the information that you already had with all those Power Query specific sources and transformations, it threw it into a data set. And the only thing I need to do is type some R code that builds another data set from this data set. And once again, to speed up things, I already have over here a bit of code which really does that. Let's quickly see whether the names of my columns are correct. Number of children seems to be okay. So if I now click on OK, my Power BI Desktop is running this code, and out of it comes this data set. So if we now scroll to the right, we can go ahead and see over here the predicted amount of taxes that you will have to pay, given my, in this case I used linear regression, one of the statistical techniques that we have out there. And then, yeah, then we can now create, of course, fancy reports with this. So we'll just go ahead, close this thing. I heard the term DAX being mentioned in the previous presentation. It's one of these keywords that I picked up, so let's write some DAX. For instance, I want to see the difference between how much tax you're paying right now and how much tax you should pay if we use our new model over there. So let's quickly add some measure over here. So let's call that the tax gap. Simply the sum of the tax that you pay right now minus the tax that you're supposed to pay. That's predicted tax. Okay. So in short, if this number happens to be positive, then you're paying now more than you're going to pay in the future. If this number is negative, then you're now paying less than what you're going to pay in the future. Okay. And then we can do the traditional reporting. I guess most of you are familiar with Power BI Desktop, so I'm not going to spend too much time on this, but let's, for instance, create a quick example. So first I want to figure out whether this thing is gender neutral. If suddenly women need to pay a lot more than men, hell will break loose, or the other way around. So men need to pay, men need to pay, well, less than 1 cent. That's to the power -9. So, okay, men and women will not need to pay much more or less than they do right now. Let's see who will need to pay a lot more. So let's go ahead and grab, for instance, their actual name in here. Okay, so this person over here is definitely overpaying. That person will need to pay 90,000 less than she does right now. Super. Let's go ahead and check who's on the other side of things. Click over here. Okay, so apparently there is this guy called Donald Trumpet who's paying way too few taxes over here. Okay, we got him. Okay, so I hope that you see that in this way we can combine the power of R with then fancy visualizations like Power BI Desktop. By the way, talking about Power BI Desktop, you can also use special R visualizations in here. Let's quickly open up another Power BI Desktop. Let's go ahead and close this one in the meantime. Questions? Ideal time for questions.
What was the predicted? Because when you show it, there was the same amount of the predicted value, and with linear regression,
Oops, I closed it already. No. It was not, because remember my tax gap was this, the wide, how big the bar was. So for some people, they paid a lot more than what the prediction was. That were the ones that had a positive bar.
It was depending on the real tax, not the prediction.
So in the model over here, what I simply did was I grabbed only parameters like how many kids do they have, what's their income, and a few of those kind of things, and made a linear model on top of that one.
The values were bad.
Sorry, yeah?
The values were, I saw there 26,000 for this tax gap in the column, maybe it's interpretation.
So the overall, so what R trying to make sure of was that overall you got the same amount of tax out of this. Whether you use the old ones or you use the new model. That's what I showed you. If you just looked at gender, it was nearly identical, the same. But if you looked at it person by person, there were very big differences between what they paid right now and what they will pay in the future. To be really honest, what they paid right now was just a random number, except for Mr. Donald Trump over there. So this was just, I mean, don't worry about the data, it's just fake data. It's just to show you how you can use it in Power BI. If I would be really working for the government, I probably wouldn't be working this late right now, so it was just some fake data. Okay, so what you see over here is, again, Power BI Desktop. But if you go like, hey, Nico, those kind of visualizations, I don't remember those from Power BI Desktop. What are those? Or like these things over here. What are these things doing over here? Well, this one is an ordinary visualization that we have in Power BI Desktop. These two things over here are examples of our visualizations. How do they work? Pretty simple. You go ahead and grab R over here and drag, sorry, not drag, double click on that one. And then for your R visualization, we just need to go ahead and pick some fields that we want to use in the visualization. So for instance, from my customer over here, let's say I'm interested in, for every customer, we want to see, well, I don't know what their yearly income is, for instance. Okay. And then over here, it generates some R code for us, and whatever is in that gray box over there, we cannot edit that one. But here at the bottom, we can go ahead and write our own stuff. Remember the hist function that we showed earlier on to plot a stupid histogram? So here is the data set, and now I can simply say, from that data set, I want to go ahead and create a histogram based on, what is it, yearly income. See how these things are distributed. And then if you click this icon over here, they go ahead, run your code, and there is your histogram. And of course, the nice thing is in Power BI, everything is always related to one another. So if I would now, right next to this chart, plot something else, for instance, based on, let's say, the gender, and we make that one filter, and I click on M, you see the bar being updated. I click on F, it's being updated. What you cannot do, unfortunately, is click on a bar over here and make sure that the rest of your chart is filtered. It's just a JPEG, but that's basically the idea. So that's the one that I did over here, but then simply with some more fancy things. So if you master the language of R, you can go ahead and create all sorts of spectacular visualizations. By the way, for whoever was presenting earlier on, for maps, they also have a bunch of maps in there. There is GG map, etc. So then you can go ahead and extend the list of maps that we're going to show. But the good news is, if you do not know R, you can still get the power of R. Because on this page over here, I have a visualization as well. You might recognize this. These are the kind of decision trees that we made in Visual Studio a bit earlier on. But if I click on that one, you see it's not R code behind it. What I did was simply this. I went into the Power BI gallery. No, the Power BI gallery. This one. And in there, you have these traditional visualizations that you can choose from. No, that's not the page I need to be in.
I think it should be Visuals Gallery.
So, Visuals Gallery, Power BI. Custom visuals.
Or custom.
custom visualizations. That one. Okay, thank you. It's getting too late for me. Yeah, that seems to be better. App powerbi.com/visuals. Okay. Oh, please. Okay. So in here you have these custom ones. You probably already know those. But if you click on this one, those are all visualizations made with R. But the R code is embedded. So you didn't need to know R. The only thing you need to have is R installed on your local machine. So what I did is I downloaded, in this case, this one for building decision trees, threw that in my Power BI desktop over here, and then told the system like, hey, please predict yearly income based on these things over here. And it goes ahead and builds the visualization for me. So users can now on the fly decide to kick out something like, oh, and what if we don't know the number of children? You remove this and he rebuilds the tree for you. So you can use it that way as well. You don't need to write some R code. Okay, with that, I would like to finish up on the Power BI desktop. And up till now, all the demos that I've been doing were running one and the same R distribution. So we have different flavors of R, and one of those flavors behind one of these doors is the one that you have in the open source community. And everything I showed you so far works with that one. But you can also go ahead and pick a free version from Microsoft known as Microsoft R Open. And with that one, you can do whatever you can do with the free open source version. But it has a couple of libraries built in to make certain things easier to do. One thing is it has a mathematical library. It only works on 64-bit machines, but in that way they improved the mathematical operations, and they run a bit faster than if you download the general version, the open source version. Another thing that they did with this one is they make sure that if you load packages, that everybody gets the same version of a package. Because if you would load a package a week ago, your script runs, you now give it to your colleague, and he runs it right now and downloads the package today. It could be a different package if you use the open source version of it. But with Microsoft R Open, you always download your packages as they were snapshotted on a particular day. And if you really want, you can choose what day is that day on which you snapshot these things. So that makes it easier to have consistent data. Microsoft R Open is open source. You can get it from for Windows, but also for Linux, for Mac OS, etc. So it's available for a bunch of these things. But now I want to shift into something else. There's also something known as Microsoft R Server. And Microsoft R Server tries to solve a problem that up till now I didn't really talk about. What if you have large volumes of data? With large volumes of data, the normal R versions, both the one from Microsoft as the open source one, they need to load everything in memory. And that will lead to a couple of problems. Problem number one, what if you have more data than memory? Problem number two, what if you have a machine with more than one core in it? Oh, doesn't everybody have a machine with more than one core in it? Yeah, but R is only using one of them. But with Microsoft R Server, what you do is you load your data, you cut it into smaller pieces, and each of these chunks of data you will operate upon on one of your cores. And then in the end, you merge all the results back together again. Sort of divide and conquer approach. That version of R is not freely available. That thing you need to pay for. These guys need to make a living as well. So you can get it in two ways. One way is inside SQL Server. If you buy SQL Server 2016, it has Microsoft R Server in it. Well, that is enterprise version. If you buy 2016 standard edition or whatever, they have a sort of small brother of that thing in there. I'll explain the difference later on. So if you work with those, if you work with Microsoft R Server, the big difference is that if you work with files, if your data is not in SQL Server but in files, you must first convert these files into a dedicated format. And this is known as XDF files. I first want to go ahead and show you a quick demo of those.
Okay, but you can use XDF file in Power BI desktop?
The answer is,
Data source.
it depends. Now, as a normal data source, well, let me show you. If you're in Power BI desktop, and we're in our options and settings over there, one of the options is which flavor of R should this thing use. So if you go for R scripting, here you need to choose which version of R that you're using. And if you pick over there the R server version, yeah, you can use these things.
Okay.
If you use the normal ones, you cannot use it. So you need to run Power BI
On
desktop
enterprise.
on your server. Okay, so for just Power BI desktop, not always an easy solution. Plus, what I forgot to mention is in Power BI, you can go ahead and upload things to powerbi.com. For the transformations that I did, they use the gateway. So you need to have a local R installed, but it could be an R server, and the gateway goes ahead and talks to your local R every time it needs to process the data. For the visualizations, it's using an R installation at the Microsoft powerbi.com website, and that one is not a server. You cannot use it in your visualizations. Okay, so let's go into this thing over here. Here I already made an XDF file, so I took a bunch of CSV files and via some R code converted them to XDF files. Simply have them over there. And then, and that's a special thing, that divide and conquer approach that I mentioned about that is so powerful in our server, it does not work for your ordinary packages and the ordinary functions. So all the functions that I showed you so far, like edit part and summary, etc., they do not work on this. You have to go ahead and use functions in a special library, which was created by a company called Revolution R, which are bought by Microsoft, so now Microsoft R. And it only works on top of these things. Does that mean we cannot use any of the things I showed you so far? Well, you can use them, because as I will show you in a minute, this thing, for instance, can convert our XDF things back to an ordinary data set. So the idea is on your large volumes, you first run RX things, which will go ahead and filter down the data, do aggregations and whatever. And in the end, if you end up with something that is small enough to fit in memory, then you can convert it back to an ordinary data frame and start doing all the plotting and whatever you want with this. Okay, so over here, what I have is a file, and it has in there 13 million rows, 36 columns. And I can go ahead and ask information about my variables. So there are 36 columns over here. You get information about what these things do. So amongst others, I want to compute the correlation. Compute the correlation. This is information about people who have a car accident and submit a claim to get back some money from their insurance. So I want to see whether there is some correlation, for instance, between how old your vehicle is and how much money you want to get back from these things. So now, what was it? What did I mention? 13 million rows. Let's do some correlation. Done. And in this case, we see that there is a small negative correlation. So the older the car, the smaller the claim that you have. Or for instance, do visualizations. Let's go ahead and build a histogram on top of this. This is, again, plotting the age of the vehicle and the number of claims that we have. So if you have a very old car, you don't make many insurance claims anymore. It's mainly cars that are 2 to 3, 4 years old that are problematic. But in this way, I could now, for instance, say, oh, from this, let's focus on cars that are more than 5 years old and for which there is an insurance claim above 300 euros. And I assume that that will not be too many, so I want to squeeze them back in an ordinary data frame. And from that moment on, use non-RX things on top of it. No, that's not what we wanted to do. Let's run the whole thing. So now over here again, he's chewing on these things. And after, what was it, 3-4 seconds, I now have a normal data frame over here. And for instance, with view, you can go ahead and show this in a window. So these are a few thousand instead of millions of rows in there. In this case, about 8,000 rows of these problematic cases that I want to investigate, and on those I can now use the ordinary libraries. Okay, so that's just a bit of an example showing you how we can use Microsoft R Server. Now, the way that some people want to use this, especially we, the SQL people, we don't want to load first data in an XDF file. We want to use the data that is live in our SQL Server and immediately run that RX stuff on top of that. So that's possible as well. I have over here, again, my RevelScaler library. I build a connection string. I'm not going into all the details of this thing over here, but this line now is important. We're telling the system that that particular SQL Server will be the compute context in which all my code needs to run. Okay, let's set the context. So from now on, I can go ahead and pick some queries over here. Would be great for the mapping thing again. Maybe you've heard of the taxi data set, the New York taxi data set. So if I remember well, we have something like 13 million taxi rides in New York, and that's what I'm now going to load. Well, I'm not going to load them. This is just a query. But if I would now say use that SQL Server data over here and read it in chunks of, what is that, a million rows at a time, he doesn't really read the data. And you see this query is done in an instant. This is just a reference to this data. Just when we go ahead and call things like compute a summary, go ahead and again tell me min and max values for all these kind of things. Only now he's kicking off this query. So now he's querying a few million rows in my SQL Server over there, pushing that data always in chunks of a million rows into the RX function, and they go ahead and compute on top of those. So, didn't I start that one? Oh, I didn't start it, sorry. Okay, so in this way the system now is computing. This will take a few seconds. Once again, just fetching so many million rows from a SQL Server could already take a bit of time, of course, and we still need to do all the statistics on top of it. But normally it's something like 10-15 seconds, and then we will go ahead and see the results of this. Hey, as soon as this one is finished, we can do more advanced things. So remember the linear regression. So over here we now see the results. It's 14,700,000 rows, and over those we went ahead and computed min and max values, etc., to go ahead and see correlation. Let's go ahead and do linear regression. I want to predict how many passengers are taking this taxi. If I know the trip distance, how many seconds it took, where we picked up our passenger, where it was dropped off, which day of week it was, which hour of the day it was, etc. So if we go ahead and run this one, again, it will take a few seconds, and then we have made a linear model. And then you can, of course, save that linear model, and in your applications, make calls to this. So whenever, for instance, in your taxi company, somebody goes ahead and calls you like, hey, you want to be picked up over there, and please take us to that location over there, you could use the model to predict how many passengers they will probably have. Or you could ask them, okay, over here. So it took 21 seconds to build this model on my 14 million rows. And if I really want, I can then go ahead and see, for instance, what has an influence. So your latitude is less important than your longitude, simply because it has fewer stars over here, etc. So in this way, we made a model, and we could now start using that model to make predictions. So I hope that with this you saw that even on large volumes of data, you can go ahead and do this kind of analysis. And to be really honest with you, there are 4 versions of Microsoft R Server. One for SQL that I showed you over here. One for Windows, where you just use XDF files. But you also have, for instance, one that can run on a Hadoop cluster. You have one for Teradata. So you can go ahead and take all these big data stores over there. And on Hadoop, this thing runs on as many servers as you have in your Hadoop cluster. So then you can really get huge performance, even if you have terabytes or petabytes of data to run upon. Okay, so that's all fine if you're the data scientist. But let's pretend that your data scientist came up with this fancy model over here. And now you're the SQL guy who need to go ahead and use these things. So you want to call them from within your Java or your .NET application. How do we call R code over there? Well, you can solve it in an easy way. If you know how to call SQL code, that's more than enough. Because if you have SQL Server 2016, in SQL Server 2016, we have this feature that you need to enable. It's called external scripts. And the idea of the external scripts is that you have this store procedure you can call. In a language, there is currently only one available, R. But I'm looking forward, maybe they're going to add Python to this in the future. Maybe Julia, if you're familiar with that one. But Julia is not stable yet, so I think it will initially be just Python. But so for now, only R. So what I tell the system is, here is an R script. And as the input to the R script, run this SQL query. And whatever comes out of this SQL query, store it in a variable with that particular name. And that's the variable that you refer to in your R script over there. So in this case, what I do is, as a query, I say, grab everything from reseller sales. This R code, what it does is, it figures out whether a column is numeric or not, and only returns the numerical columns. How would we do that in T-SQL? Writing a query that only returns the numerical columns and not the string columns without hard coding which columns those are. And once again, R is sometimes easier for certain things. So let's run this, and there I get back a bunch of columns, and these are only numerical columns. But you notice one problem. That's something that I hate about this product. If you do not dictate what the metadata will be of whatever you get back anonymous columns. You lose your column names. So that's why in most cases where you do know which columns you're going to get back, you write it in this way. So if you call a store procedure in SQL already for a few versions, you can say with result set and dictate the column names and data types that you will get back from this. And if I run my code that way, then the system knows how the column name should be. But in my example, then it's less useful, of course, because the purpose was to figure out which columns these are, and now I need to know the columns before I can run it. But if I call it this way, we get our information. But the idea, of course, would be that if you made a machine learning model, over here you don't call this kind of code, but you call the kind of R code that from your machine learning model and from whatever you feed into the system over here, it predicts, for instance, how many passengers the taxi will need to have, or whether a customer will pay back its loan, or whether the customer will go over to the competition, or whatever. Microsoft did a nice demo on the SQL Pass conference a few months ago, where they had a machine that made 1 million predictions per second based on these kind of things. It was a heavy machine, but nevertheless, 1 million predictions a second, that was impressive. Okay, so let's end with one last demo that is based on that idea that I showed you a minute ago over there. Reporting service, another technology that was mentioned earlier today. So what I do over here is, in this reporting service report, I want to show a chart computed by R. Again, I'm predicting who's going to buy a bike. I know it gets boring, but if I run this report, you will see over here a decision tree, once again predicting who does not or who does buy a bike based on a bunch of criteria. And if I would now, for instance, go ahead and say, well, decide this for another region over there, and you click, it goes ahead, builds another decision tree and show that over there. Those of you familiar with reporting service, you probably think like, there is no R thing to throw into reporting service. I have this tiny toolbox with just a couple of things in there. So how can you do this? Well, pretty easy. So a few more minutes and we're done. Let's go ahead and open up some project that is not in the list. Okay, let's see whether I can quickly find that one. Here, that's the one that I was searching for. I gave it a really original name. So what I did is simply this. In a reporting service, one visualization that you have is show an image. Okay. So the only thing I did was from my toolbox, not the SSIS toolbox, the R toolbox, I dragged in this image thing. And when you configure your image, you can say, well, my image comes from a query. So it comes from the database, and there is this query, and it returns an image. You see the ID? The query that I kicked off, now Nico, over here, the query that I kicked off for this particular one was not deleted, was simply call some store procedure. And what does that store procedure do? That's this store procedure. It goes ahead and builds an R script, and that thing over here is doing the plotting of a decision tree, etc. That's the kind of thing we saw before. I feed into that thing the query that needs my data, and it will go ahead and build the necessary, it will call the R code, and that builds the necessary image. To be really honest, I need to do some extra plumbing over here, because in R you need, if you normally call a plot statement, like I do over here, that plot goes to the live screen. I don't want that, of course. I want to push it into a PNG file over here. So this is some extra plumbing code. If you're interested, send me an email. I can let you know how to do these kind of things. So I dump this into a temporary file, and I return that file as a var binary max. And then it's picked up by reporting service, and in that way I can show my visualizations in there. But once again, this only works on a SQL Server 2016. The report server doesn't matter, could be an older one, but the SQL Server needs to be a 2016. Okay, so with that, let's finish up. I didn't do any slides, but I guess since it's that late in the evening, you don't really were waiting for more slides. Yeah, sure, shoot.
Was this image because
Oh, sorry. Yeah.
no, the image itself.
Yeah.
It won't look ugly because
Well,
you can
well,
choose the size of this image.
well, yeah, you can. So that's my tricky plumbing code over here. So, ooh, Nico, that's not what I wanted to do. Sorry. In my code over here, you will see. I can go ahead and move this thing a bit further down. So what I did is in my R code, this is some extra R code that I will put in front of the R code that you submit over here. That's my extra plumbing. And in there I say, create me a PNG. And here I can control the width and the height. So these are parameters. In this case, I hard-coded them to 500 pixels. So in that way, you can make this an extra parameter that is provided by reporting services. Over here, it's just hard-coded. And another thing that I did was, well, I was not creative enough to come up with all of these things myself. I found it on the internet. But the people on the internet, what they did is they used JPEG. And if you use JPEG, you get all these kind of rendering issues. If you ever took a line drawing and put it in JPEG, then it gets fuzzy on the lines. So I simply switched it to PNG instead of JPEG over there. But then, of course, you need to make sure that if you run it in your report for this thing over here, you as well tell him to run it as a PNG, because it doesn't have a file extension, doesn't know what's in there. But in that way, you can control the width, you can control the height, and you can control whether it's time to stop talking. Okay, so in that way, you can make sure that the quality is quite okay. Now, to be really honest with my example over here, it's a bit of a stupid example, because what I do is every time you call the report, I also build the model and then show it. In reality, you would build the model up front with maybe all these heavy things with RX stuff, etc. And just over here call the visualization, the plotting part. But in this kind of way, yeah, you can go ahead and integrate R. So to wrap up, we have a couple of versions of R. We have Microsoft R Open, which I used for my first demos, Microsoft R Server, the commercial one for the more heavy things. You can go ahead and render it in SQL Server, but only in SQL Server 2016. Enterprise Edition. If you do not have Enterprise Edition, you get R as well. And you can even call those RX things, but it will load everything in memory. So it only runs on data sets that are small enough to be loaded in memory. And it will run not single-threaded, but on 2 threads, no more than 2. With Microsoft R Server, it runs on as many threads as you want. So you get much more parallelism. We saw the integration with Power BI Desktop. So with that, I more or less hope that you get a bit of an idea what is possible with R in this in the Microsoft world, and that you see that with the skills you already have, like Power BI Desktop, like SQL, reporting service, if you just add a little bit of R code, you Google or Bing a little bit, you can go ahead and do much more than what you can do nowadays without having to write too much code. So with this, I would like to thank you for attending this session, to stay here this late without the pizza. I hope it gives you a little bit of an idea what you can do. And I still have room for questions, and I would say that maybe the first two brave ones to ask a question can go home with one of these. So, who starts? I go home with 2 bags. Yeah.
Nobody was
Sorry.
expecting this, right?
Sorry?
Nobody was expecting this kind of outcome, that you give away these backpacks for asking questions.
I can't help. I don't know. I don't remember who. But we have the video.
Figure out who came up with the original question. No, I was asking for questions now. I know the question.
The result of this linear regression was really the same for every. And you can say
Okay, so 2 more minutes. Let's go ahead and show you. I anticipate questions sometimes, so I stored over here an earlier versions of this demo that I did. So this was the Power BI stuff. Okay, bear with me while this is loading. In the meantime, think of a second question.
Okay, how efficient is that? For example, if we have 1 terabyte of data and we want to cancel it on the cloud, how much time it will take?
So you plan on doing this in Visual Studio, and you have that virtual machine in the cloud, and you have a terabyte of data, and you need a virtual machine with a terabyte of RAM.
Yes, so in a virtual machine, how much time?
Now, for those kind of things, if you have that kind of data volume, you really need to go and use the Microsoft R server, because that one can take whatever volume of data you have, cut it into smaller chunks, and run things chunk by chunk. So if you have more data, you'll simply need to wait longer, but you don't run out of memory. And you can, of course, run Microsoft R server in a virtual machine in the cloud if you want, or you just run it on-prem. If the volumes go for more than a few terabytes, I would really suggest to go into the Hadoop solution and run Microsoft R server on Hadoop. And that is easy to do, because if you go to Azure and you have more than €1 credit left, like I have, you can build an HD Insight cluster. And there you already have an option to say, give me my HD Insight cluster with Microsoft R server on top of it. And then you just go ahead and throw all your files in Azure storage or Azure Data Lake storage. And you go ahead, kick off your R scripts, and they will run with those RX things in parallel and all of these things. And then how fast does it run? That depends on how many nodes you throw in your cluster over there. It's not really super fast, in the sense that there is always some overhead of kicking off these things and combining all the results again. So don't expect like sub-second response times, etc. It's more for batch processing. Although these things can now also be combined with Spark, and then they run again in the memory of your Hadoop cluster machines. So you're more limited on the data volumes you can process, but then you get great performance of it.
Okay, can you use RiboScale in Power BI Desktop?
Sorry?
Can you use RiboScale language in Power BI Desktop?
Only if you go ahead and connect your Power BI Desktop with only if you connect it to Microsoft R server. And once again, that means you need to run Power BI Desktop on your server. So that will be a costly experience. So it's possible, but it's via remote desktop connection or whatever. So to come back to your question over there, were all these numbers the same or not? So over here I have my data.
They are the same, because my question was, I thought that I need to ask the question for the other people, why are they the same? And the person who say why they are the same gets the pack.
Okay, so you have your answer?
No.
So they're not the same. This is what people were supposed to pay. This is what the system predicts.
It's the same. Why?
Oh, these values are all the same. Well, that's simply because all of these people have the same number of houses, the same amount that they paid for their pension fund, the same number of companies that they have, and the same number of children. So if we would scroll further down. Okay, so tax should be fair. If you have the same inputs, you should get the same output. It's not because you know a politician that you have to pay less. But we can make that an extra column. Yeah. So yeah, they were not always the same, but it was simply if your inputs are the same, your output is the same. It's not a random data generated at predictable.
It's strange because the facts is random. So there is the regression between the inputs and the random. There should be no correlation, as you said, the tax declared is random.
Well, for instance, if you take a look, I think if you have more houses, you pay more taxes.
Yes, but you have said that it's random, so it's not the random.
There is a random factor in it. It's not entirely random.
Okay. If it's random, there is no correlation.
You're absolutely correct. So, for instance, if we would go ahead and take a quick look, dependent on, let's say, how many houses that you have, let's see how much tax you had to pay, and then you see if you're higher up, you pay more taxes. So I added a random factor and I added a deterministic factor. That is the joy of playing with data and building data sets with R. It's just a few lines, and then you can generate this data. Okay, is it okay to wrap up over here, or is there still some urgent question you cannot get to sleep without the answer? If not, thank you for attending. And I would say